Good morning, guys. Hope you're having a great day with Mrs. Fish. So today we're going to learn about properties of tangents. So first, I want you to draw a circle and a line. So for example, we could have something like this, circle and a line. We could have a circle where the line goes through it. But what we want to talk about today is a circle with a line that meets at exactly one point. So if you take a look, this circle and line meet at exactly one point. And what we're going to learn about today is what this line is called. This line right here is what we call a tangent. Okay? The important thing to understand about a tangent is a tangent to a circle is always going to form a 90-degree angle with the radius or the diameter. So a tangent is going to intersect at one point and then form that 90-degree angle. So exercise 1. It says CD and CE are tangent to circle A at points D and R respectively. Prove A equals B. So you can see A is this side right here, B is this side right here, and we want to prove they're equal. So where we can start is we can take a look at our diagram and we can actually draw in our radii AE and AD. And I'm going to relabel that guy A so you can see. Now, if you remember, what do we know about radii? Radii, we know they are equal, so I can go ahead and mark that AE is indeed congruent to AD. And then, because I want to prove A and B are congruent or they're equal to each other, we have to have triangles. So if I draw A to C, I now have triangles. So in order to prove triangle, we want to prove triangle ADC is congruent to triangle AEC. So right now we currently have one side. If we take another look, you guys can probably notice that we also have AC, which makes a second side by the reflexive property. And then, based on what we talked about just up here, a tangent is always perpendicular to a radii. So if we look back, here I have a tangent, which is DC, and a radii AD, so I know there has to be a 90-degree angle here. So if I have a 90-degree angle there, now I have three pieces. The problem is that I can't prove it congruent by angle side, because that's our bad word. So instead, if we take a look, we have hypotenuse, which is AC, and leg, AE, with a right triangle. So I indeed can prove these guys are congruent by H and L. Okay? So what this helps us tell is it tells us that any tangents that meet at the same point out here always have to be equal. So let's do exercise 2. It says in the circle the radius is 9 millimeters, so I can go ahead and draw in my radii, and I can label it 9 millimeters. And BC is 12 millimeters, so this guy over here is 12 millimeters. It says find AC, so I want to know what is this length here. Now, so this guy's going to be our x. Remember our properties of tangents. Tangents and radii make a right angle. So if I'm looking for a missing side with a right angle, remember I used Pythagorean theorem. So I can come over here and say a squared plus b squared equals c squared. I want you to go ahead and finish this by yourself. I will check this on Monday. So go ahead and finish. If you need to, pause the video while you finish, and then you can keep going. Now it wants you to find the area of triangle ACD. So if you take a look, now we want the area. So in order to find the area, and remember this guy's A, our area formula is area equals 1/2 base times height. Our base and our height are always the lengths that meet at the right triangle. So we need this side and we need this side. This side, because it's another tangent that meets at the same point out here, C, it has to be 12. And this, because it's a radii, has to be 9. So same thing, I want you to go ahead and finish this guy as well. And then find the perimeter of quadrilateral ABCD. So you can take a look and you guys can go ahead and find the perimeter because you guys have all those measurements now as well. So go ahead and find the perimeter. Remember, the perimeter is we add up all of the sides together and that's what we get. Oops, sorry. Exercise 3. We have EF, so this guy here is 12. And AE, if I draw this guy in, is 13. And it says AE to AC is 1 to 3. So if AE is 1, that's the same thing as saying 1x to 3x. So if AE is 1, then AC we can draw in, we know has to be 3x. So we can do 3 times 13. 3 times 13 is 39. So we know that this guy over here has to be 39. It says find the radius of the circle. How am I going to find the radius? Well, if I take a look, we know that here's a radii AF, and they meet at a right angle. So I can use the Pythagorean theorem to go ahead and find my x over here. So I have a squared plus b squared equals c squared. So I have 12 squared plus b squared equals 13 squared. 12 squared is 144 plus b squared plus 13 squared, which is 169. I can subtract 44 from both sides. So I'm left with b squared equals 25. So b equals 5. So my radius is 5. Now it says find BC. So if I take a look, BC is this guy over here, but we can do the same exact thing. We can connect our radius, and we know that radius is now 5. So now I can go ahead and find x because I have to have a right angle. So I want you to go ahead and find this guy by yourself, part B. Remember, a squared plus b squared equals c squared, and you're rounding to the nearest whole number here. And then find EC. So EC is this whole length. Well, if I know that FE is 12, then I know that ED also has to be 12 because they are tangents that meet at the same point. But then I can go ahead and find this guy over here because this also has to be the screen X after I find it. So then you can go ahead and just add these two together. So once you find part B, go ahead and do part C. Okay? Now, that's all I have to tell you guys about tangents. So what I want you to do until the end of the period is just to continue working through this packet using that tangents, make a right angle with the radii, and that two tangents that meet at the same part are equal. If you need to skip around, that's okay. If you need me, you can message me on Google Classroom, and I will be around to answer it today.